Hi, welcome to Chapter 4. Try to get this all squared away. Let's see. Okay. So this chapter's on wireless LAN clients. Just talking about major capabilities, major devices, and what some of them do. So some of the objectives that are covered definitely describe the type of clients, and we run into various types. From laptops to specialty devices, video cameras, Wi-Fi cameras, your laptops, printers, you name it. And then what channels most of these devices work with. So those are some of the topics we'll cover this chapter. Now, laptop devices, I'm recording this on my laptop, so hopefully it comes through. But in most cases, they're probably some of the earliest wireless clients to exist. They started with PC card adapters, and now most of them have internal adapters or built into the motherboard itself. Most of them have a half-mini PCIe adapter that's on the motherboard that can be changed that handles the 802.11 information. Most clients today come with either 802.11n or 802.11ac adapters. Now those with 802n may be 2.4 gigahertz only, but in some cases you may get a dual band where they're 2.4 and 5. Now, as you know from the protocols, 802.11ac are always dual band, but usually it's 5.0 gigahertz. Now, if your laptop has a single band, most likely it's going to be 2.4. Very rarely will you just see a 5.0 single band laptop. Now, as far as different types of USB adapters, some of them, this is where you can get access to putting your wireless adapter through a USB slot. Some of the earlier machines, this is the only way you could have gotten in because they didn't build adapters on either motherboards, especially like for desktops. You would get adapters like this to allow wireless capability. Now, they come in a wide variety. You've got the USB 2.0 and USB 3.0. Now, there's a big difference between this now. Granted, the USB 2.0 has maximum throughput of 480 megabits, where 3 can go up to 5 gigabits. But you know that the 802.11 standard probably can max you out at 450, so 2.0 works fine. 802.11ac can go up to 5 gigabits, so that may be an option for you. But one thing to keep in mind is that 802.11ac, even though they operate in both bands, they can cause interference in the 2.4 megabits or gigahertz range. I'm sorry. And so if you're going out doing testing on a device, you may want to lean towards the slower 2.0 USB device, just so you're not causing interference that to overcome. Now, as far as your tablet and mobile devices, again, the chipsets 802.11n and 802.11ac, some of the older ones only have 802.11g. So just something to keep in mind if you got older equipment on your premise. Somebody comes in with an 802.11g, you end up, what do you have to do? I got to go to the lowest common denominator. So you would slow down the network altogether. Most tablets, as far as operating systems, you got Apple's iOS and you got Android's operating systems. Yeah, there may be a few Microsoft Windows phones out there, but I think for the most part, I think that's you're going to see the iOS and the Android phones going to be the most likely. Now, mobile phones, they're definitely smaller than the tablets, and they both allow either Wi-Fi or cellular capabilities. If you're getting a new one, it probably comes with both. I got an older iPad and I only get Wi-Fi. I don't get cellular coverage in those cases. Just something to keep in mind. Now, mobile phones commonly are single and dual band stream systems, and that's not likely to change anytime soon. Because the reason they're trying to do this is to balance between battery life and wireless speeds. So you're not going to get a lot of multiple stream devices. It's going to stay with single stream just to save battery. And you probably will see that type of a question on certification exam. Just thought I'd throw that out there for you. Now, desktops or wireless desktops. Of course, I don't think I've ever had a wireless desktop. My desktop at school only has, I got no wireless on it at all. And it's actually a good recommendation on if you got a wired network, it's better to use the wired network versus the wireless. Maybe as 802.11ac gets more prevalent and more old equipment is weeded out, that maybe they'll migrate that, but you still get most offices will have you 100 megabit data transfer rates, and so it's probably more than enough for most of what anybody has to do. So most of the time is you're going to connect it through using one of those USB adapters if you don't have a wireless desktop. Now, there are several specialty devices, and they can be security alarms, door locks, smartwatches, ID badges, voice over IP, medical equipment. Most of these run at the 802.11, well, I should say, let's back up, 2.4 gigahertz range. And some of the chipsets they're using are actually the 802.11g chipsets. So even though you'd like, even though that slows your network down, and sometimes people go, well, let me just swap all that stuff out. But in some cases, based on what equipment and databases that these devices tied back into, upgrading all those could be a cost that your company may not want to incur. Even though you may get slower performance when these are around, just something to keep in mind. Now, these devices also have very low output power capabilities. So you're talking in milliwatts, compared to 100-watt, output. So there are 100 milliwatt output out of an AP. So they end up being not a whole lot of power. Now, when you're looking at things, you want to double check that most of your devices today usually come with single band clients and support only one band only, and it is usually 2.4 gigahertz. Some of your devices could have a multi-band, and that would be 2.4 and 5. Some of the real new ones are offering support up to 60 gigahertz, and of course those would have to be the ones with the 802.11ac chipset. So just thought I'd keep that in mind. Now, there's a tool out there as far as what devices support what channels, and Mike Albano has a database of clients, different devices, and what region they offer, what version, and which channels they operate. And per your homework, you'll see this screen doesn't show it, but it'll actually give you a Wireshark reaction to, capture on that device, so it allows you to, see what that looks like if you are capturing this stuff in real time. Most of these devices, 2.4 gigahertz range, support channels 1 to 11. Laptops can configure to operate in channels 12 to 14, but 14 is not used in the US. It is used in Japan. Since 2.4, I would just know that you're planning for channels 1 to 11. Of course, when you're doing your channel planning, basically we've talked in the past, you got 1, 6, and 11 are the ones that will give you non-overlapping channel arrangements. Now, 802.11n devices will not typically support channel 144 because it was introduced in 802.11ac. But other than that, I think most of your newer laptops will handle all the other 5 gigahertz channels. So in this chapter, there's some things you want to keep in mind. One is client devices include an 802.11 chipset. But you have to look at that chipset to define which physical interface and spatial streams they support. If a client uses a chipset supporting 3 spatial stream, the client may not implement all spatial streaming on its driver. So you just got to pay attention to what the driver and the devices handle. Laptops usually ship with an internal wireless adapter using mini PCIe or half mini PCIe variety. Desktops usually integrated on the motherboard, but they may use PCI adapters or a USB adapter. Mobile phones and tablets try to strike a balance between their speed and battery life. Most devices are 2 streams or fewer, even though the higher 802.11 AC allows for more streams than that. Specialty devices often use older chipsets, 802G or 802.11n, so you got to keep that in mind. USB devices come in both USB 2.0 and 3.0, and even though USB 3.0 is several times faster than 2.0, 3.0 devices often cause interference locally in the 2.4 gigahertz band. So you just got to be careful where you're using that. If you're doing a test in an environment, then you may want to use the 2.0 USB just so you're not inducing interference. And then protocol analyzers work with specific USB devices and internal adapters, and just making sure you select the one that captures the needs you're trying to test for. So hopefully this gives you a rough idea a little bit on some wireless devices, and I'll talk to you later.